Arrays are reference types. At their very heart, they're just what we went over before in that first video. They're a sequence of the same data type, all fixed size amount of them, all contiguous in memory, etc. But they're really kind of an object too, which we won't get into too much depth right now. But what you need to remember is that the array variable right here either has no value because you I swear haven't assigned anything to it yet, or you will assign it to an array. So this is using an array initializer. So these are all integer literals. 12 is literally an integer, like 1, 2 in your code is literally an integer data type. So I have a comma separated series of them. These are going to be the values of my array. So this is number sub 0, number sub 1, number sub 2, number sub 3, number sub 4, number sub 5. But the actual value of numbers itself is the address of this object in memory. It's not, numbers, the word numbers, the variable here, doesn't somehow have all these integers to the right of it, somehow packed inside of it. What it does have is a location in memory where the thing that holds those numbers is. So this is known as a reference type as opposed to a value type. To compare it, if you had an integer variable like int x, for example, let's give it the value of 8. If you look into it, if you look at the bit pattern of the memory space that x is contained, the thing that's labeled x, the contents of that, it'll be 32 bits. It'll be the 2's complement representation of the value 8 in binary. 2's complement, that's kind of redundant. 2's complement is binary, but it will have the value 8. But the value for numbers will be some weird hexadecimal memory location. That's two different kinds of things. This is a value. This has a value in it. This has a reference in it. A reference, a pointer, an address. I don't know what are other words for it. A handle, maybe, that refers to something that's bigger than just a value that contains all these things. You got to keep in mind each one of these is 32 bits. Each one of these literal integers is 32 bits. You've got 32 bits times what here? 6 put together. So that's more manageable if you package it up in some big thing called an object, and then you give a reference to it. So think of it like the address of your house tells you how to get to where your house is, and then if you need any particular thing inside a room in your house, you would have to go in and get it. Those would be the elements, as opposed to, I don't know, the number 4 representing how many rooms you have in your house or something. I don't know. Analogy's breaking down, but you get the idea. So why I'm talking about this is because a couple of things we're going to be working with right after this video will need to have that knowledge. You'll have to have that knowledge in your head. So let's just show this example. What I've done is I've added a list box from over here to this form. We haven't learned about them yet, but don't worry, you can sort of like get a taste of what they do here in this example. I renamed it LST output just because it's going to handle the random, not literally random, but the arbitrary output that I'm just making up for these arrays, so you can see how they work. So let's look at the code. And again, I double click on the button here. It takes me to the event handler. This is where my work's going to be going on. So I create an array with an initializer. I assign its reference to numbers, and then I iterate over, so ignore this for now, the values. I iterate over the array, and I add each element. This is an element to the list box on the form. So when I run this, we'll see how it works. It's pretty straightforward. I just click do array demo, which will take us to this part of the code right here. And what it'll do is it'll iterate over this array that I create over here with numbers pointing to it, and it will add each element to this list box. That's all a list box does. All right, so what I need you to see now, let's get this out of the way, is that if you assign the value that is inside it does have a value in it. The value is a memory address. The value is a reference. So if you assign whatever this is holding in memory to this variable over here, which is also a variable of integer array type, then let's see what happens. I run this code. My little box appears over here. So I have to click do array demo to make this do array stuff happen. And you get the same results. Why? Because they're both pointing to the same memory. They're both pointing to this. So values has the address of that array because numbers had the address of that array, and you assign that address to values. So now both of them have that address. So this is what we mean by reference type. If I actually, let's just do something here. I want to show you just to further drive this home. If I say value sub 2, for example, sub 3, gets something that will stand out to our eyes. I'll do an extra 6. So if I change one of the elements in values, let's see what happens. Obviously it changes, right? But what if I change this to numbers instead? So instead of seeing what I changed inside of values, let's see what numbers has in it after I change values. I need to make this appear over here every time instead of over there. So you see, they both have the same change. Why? Because they're both pointing to the same array. So keep this in mind, and in a further example video, we'll see why this matters.